This conference will now be recorded.
Welcome to Isha Training Solutions Demo 2 session. Basically, today what we are going to see is that we have that understanding. We had that understanding in the previous demo session that why we are actually moving to performance engineering learning things. Okay, say we don't have answer for certain things. Say I'm working in performance testing team for 7 to 10 years, and my customer is asking a lot of questions to me. Say where my time is actually spent. Is there any solution that you can provide with respect to CPU issue? Is there any solution that you can provide related to memory issue? Like that, these are unanswerable questions for the performance testers because their skill set is not that one. Okay, because they don't know all these things, right? Like if I suddenly ask you in this forum, those who are working currently in performance testing team, if I ask you uh, what is deadlock, where you will find the deadlock, what is your thread dump, what is your heap dump, what is your minor gc, what is your major gc, what is stop the world scenario. Like that, if I ask these questions to you people, those who are working in performance testing, they'll say like, no, this is not my job. I never done this activities before. I never heard of these things before. That is what the usual answer we'll be getting. Because day in day out, what performance testers will do, they will actually prepare the script, do the execution, prepare the report, provide it to the stakeholder. That is the maximum thing we usually do, right? Uh, uh, but in realistic world, the expectation is little beyond that. Think about your agile world, or think about your DevOps world. Everybody is talking about full stack. You need to be full stack developer, or you need to equipped with end-to-end knowledge. That is what everybody started talking. I hope in this forum, anybody, any organization, you guys are following DevOps. Anybody in your organization, you guys are following DevOps? Okay, thanks, Troy. So, Dhanashree, in your team also. Okay, so what is that meaning? In DevOps, Dev and Ops are integrated together. They wanted to make the product to be reaching to the end user in a shorter span of time, and finding the bottleneck also in a shorter span of time. For that purpose only, this DevOps comes into the picture, right? So in that case, each one should be equipped with their end-to-end knowledge. You cannot segregate, or you cannot define a boundary that I will do this task alone. It is expected that you should be knowing other things also. So that is where this performance engineering concepts also comes into a major impact. If you are no, if say you are traditionally, I'm saying, you are providing a performance testing report, say like 10 seconds it is taking for purchase transaction, you are saying, and along with that you are saying that 10 seconds it is actually more spent in database and more spent in application logic, that to a particular link, that to a particular image, that is actually spending time. Like this, if you are giving the information, then the receiver end will be very, very happy, because for them, they don't want to do any investigation, because you are giving exactly pointed problem statement. So everybody will get happy if you are giving this kind of a pointed recommendations or pointed observations. Because think from a developer perspective. Somebody is coming and saying like purchase transaction took 10 seconds, means what is your mind will say like, There are lakhs and lakhs of code is there. This guy is coming and telling me 10 seconds. Where can I go and do this investigation? That is what usual mindset of the developer, right? But if you are telling exactly where, which method, which object, which link, which image, like that, if you are trying to provide information, that's all. It is a cakewalk for the developer to easily go and fix the issue. So that is what your performance engineers are basically doing. Performance engineer task is what? It is to be pointed solution, pointed information. Either two ways, guys. Performance engineer, either they do recommendation or they do fixing itself. Two way. Either they do recommendation or they do fixing. If you have environment access, code, source code access, all those privileges and permissions that performance engineer is having, they can straight away fix the issue, or else they can recommend it. They can recommend the respective team to do that activity. Say like infrastructure team to do the scaling, UI developer to do the optimization, DBA to do the fine tuning of the query. Like that, each and every team they can do the recommendation, or if they have the access, they can do the fine tuning that activity. Can confirm the need for full stack. Say try say like you are having a knowledge on particular activity alone. Okay, in that case, you cannot recommend anything on the other places, say like DB side or infrastructure side, or any UI piece of code. So once you have a fundamental knowledge, not the deeper knowledge, once you have the fundamental knowledge on other zone also, then you can at least talk technically, recommend something, ask them to fix it, and then it will be a coordinated effort to fine tune your application. That is what full stack. Full stack. The two in the recent trends, these APM tools are started saying like we are full stack monitoring application. This Dynatrace tool and all, they started saying full stack monitoring. So which means that
Hmm.
what? UI till the server, UI till the infrastructure. That is what they are trying to focus on. Try. Okay.
Yeah, I was agreeing with you. I was just saying that there's a lot of focus on DevOps and the need to be able to go in and give pointed recommendations, like you said, or be able to actually go in and fix. Like that's what when you're working on these Scrum teams, that's the expectation. So yeah, I was just confirming. I was just agreeing with you.
Yeah. Thank you, thank you. So all these are real time, real world example, guys. Why I'm saying, wherever I'm interacting with, whichever the account that I'm interacting with, because I usually do this due diligence, gap analysis, and all, right? Where I'm interacting with the team, these are actually the problem statements. If you are talking to those people, the end of the day, what they will say, we don't have right team to do all this tuning, optimization, those things and all. So that's where the performance engineer role is also very, very important. And you think from stakeholder side, say like say like you are a performance tester. Example, okay, performance tester. Some 12 years performance tester experience, 12 years experienced performance center tester, and you are doing scripting, execution, reporting. Okay, with the 12 years experience, you are trying to do scripting, execution, reporting, and you are not doing anything more than that. And look at the experience level of 3 years experience guy. He is also doing scripting, execution, reporting. Okay, what as a stakeholder I will think with these two people, what I will think if you guys are doing the same activity, the scripting, execution, and reporting, what will I think, guys? Anybody can say.
What do I need this guy that's been doing the 12 years? Why do I need him?
Wonderful try. Actually, that is how the intention of the stakeholder will be there. What intention of the stakeholder will be there, like You are a 12-year experienced guy. If you are trying to do the equal job of what a 3-year experienced guy is doing, then why should I pay this much of money on you? You should do +1 when compared to that guy, that 3-year-old guy, 3-year experienced guy. That's where this performance engineering things are comes into the picture. Everybody will talk about, say, like over the period, over the period, if you are trying to do the repetitive job, people will not accept it. That's the IT industry logic. IT industry, what they will think, early into your career you do what you do, but later part of the career you should not say like I do what I do. You should say I do what others are able to do also. +1 I can do. That's where you are justifying to what you are doing, right? So in that case, you if you are simply say like I do only performance testing activity, no, no, you should do extra. That time only you are going to say no, I will do single user performance testing. I do code profiling things. I do heap them, I do thread them, I do garbage collection understanding, I do APM tools, I do profiling tools, like that. You should be expanding your knowledge, you should be extending your information, so that you are justifying to what you are doing. You are increasing in experience, increasing your knowledge set. The way you are doing things will be matured enough to show the difference between the 3-year experienced guy and 12-year experienced guy. That's what, as a stakeholder, you'll expect. I'll take a pass here. Anybody have any question, please ask your question, please. uh, Dhanasri, you could put more light on that word resilient engineer, Dhanasri. What is that? In your organization, you guys are following this term? No, I think that is pertaining to their uh, software alone, instead of more focused on hardware related, infrastructure related things. If they are only focused on software side alone, they would have asked that point, Dhanachari. Okay, that is like, you are trying to focus on more software engineering things, right? That time you can talk about those topic. But performance engineering is something that you are trying to put more focus on the performance itself, performance attributes, like speed, response time, hits, throughput, all those things you can do. But the site reliability engineers, they are kind of a bridge between your developer and your operations team, to totally focus on your software engineering related things alone. Okay, and then they'll try to put more effort on the operations, but primarily they are software engineering related people. Clear, Dhanasri? Clear? Yeah, you're welcome. So today what I'll do as part of our demo 2 session, no, I'll show a small example of what we are going to do in our regular session. Okay. Um, but it will be covered again during our session, but for our demo session I wanted to show you like how we can typically understand certain things. Okay, so what will I do? I'll start the Eclipse. So we started the Eclipse. Okay, I have a not I have a, everybody will have it. Maybe you can go to your Java JDK folder. Java JDK inside the bin folder. You will definitely have a JVisual VM. You try to open this JVisual VM. So what I am right now going to show you, say like you are a developer and you are doing a certain piece of code that you are trying to locally execute and validate. That time you wanted to see to that like whether you have any problem in your the piece of code that you have written. Okay, that is what we are typically doing here. It is kind of a locally when you are doing the unit testing, you are doing your monitoring as well. So say like I have a program. Okay, the name itself actually deadlock program, but you think like you have a small piece of code that you are trying to execute it. Say like I'm executing this program in my local machine. Okay, consider my laptop. Okay, I'm executing that program. Okay, that time I'm going to JVisual VM. Okay, in JVisual VM, all your locally executed JVMs will be detected, right? So that is the behavior of this JVisual VM. Either you can do a local detection or a remote detection also. Remote machine JVM also you can detect it. For now, this Eclipse is there in my local machine, and then this JVisual VM also running in my local machine. So what is my understanding? My understanding is that I wanted to see my locally executed program. So this is my locally executed program, right? This JVM is actually detected. Your understanding is all your Java programs are running in Java virtual machine only, right? JVM only, right? So I started monitoring this program that I was executed, right? This one, this deadlock program that I executed, that I am trying to monitor in this tool, this JVisual VM tool. So fundamentally, what I can do, I can go to the monitors tab. Okay, I can go to the monitors tab. See to that, is there any CPU? Is there any memory, class level, thread level problem or what? Okay, first of all, I have these four in investigation things that are available. And then I feels like, okay, nothing is actually a problem in this CPU, memory, class level, thread level. I did not find any abnormality. If I feels like that, what I can do, I can go to the threads tab. Okay, so under threads tab, the wonderful behavior of this JVisual VM is that like it is able to detect if there is any deadlock available in your program. Okay, so say like you executed your program, and JVisual VM is actually monitoring your piece of code. That piece of code is actually having a deadlock. That we found it using this JVisual VM. So usually thread dump and heap dump. Okay, thread dump is nothing but threads that are running at that moment of time. At that moment of time is nothing but when the issue is happening. When the issue is happening, at that moment of time, what are all the different threads that are running? Okay, say like in this scenario, there are different threads are running. In that time, there is a deadlock. That moment I wanted to take the thread dump. I'll repeat again what is the thread dump definition. Threads that are thread snapshot. Okay, threads that are running at that moment of time when the issue is happening, right? That time. So say like I found like there is a deadlock happened. So I wanted to typically take a thread dump to understand what is really happened. Okay, so this is just one way to, this is one of the way to trigger the thread dump, guys. During our regular sessions, I will be showing you in what are all the different ways you can take the thread dump, different ways to take the heap dump, all those things, and even different ways to analyze your thread dump with the different tools. All those explanations would be there. For now, I wanted to show you a very normal thread dump capture and analysis. Okay, so here the program executed. That program is monitored by JVisual VM. That moment I took the thread dump. I'll take a pass here. Till now, any question, guys? Okay. So basically, we took the thread dump. Now we are going to have a investigation that we are going to do. Okay. Same kind of tools will be used in all projects. Yeah, Kumar. Actually saying this JVisual VM or JConsole or this JProfiler or this your kit, these are the repeated tools in most of the places they'll use, Kumar. That too, this JVisual VM is open source, right? Open source in the sense like there is no cost involved. Inside the JDK it is there, right? So everybody will use this. Okay, Kumar? Yeah, you are welcome. So we took the thread dump now. Now I wanted to investigate what is that really happening, because there only the critical things are involved, right? Say like I am going to see the traces. Okay, there are different traces are there. In that, first of all, the thread life cycle is like this: new, runnable, waiting. In some cases, it is timed waiting, blocked, terminated. This is the life cycle. During our regular classes also I'll explain the same. For now I'm going to explain the scenario, right? That is the reason I'm repeating again. New threads, runnable threads, waiting threads, timed waiting threads, blocked threads, terminated. Okay, blocked is the first thing that you usually check it in your call trace. Okay, so blocked threads, is there any blocked threads that are available in your thread dump or what? Okay, and I'll repeat you one more thing. Thread dumps, whenever you are taking a thread dump, you should take minimum 3 thread dump or 5 thread dumps. Minimum 3 thread dumps and 5 thread dumps. Why you have to take 3 thread dumps or 5 thread dumps? Because the issue will be infinitely happening or very shorter span of time if it is happening. That is what you have to find it. The issue is happening indefinitely or very short span of time it is happening. Say like I'll give you an example. Okay, I gave one print to a printer. Okay, printer, I gave one print to a printer. In the same time, Jonathan also gave print to a printer. Okay, what will happen, guys, in this scenario? Anybody can explain what will happen? I gave print first and then Jonathan gave print second. What will happen in this case?
Maybe the first one would have got executed.
Okay, till then, what happened to Jonathan request?
It will be in the queue.
It is in the queue or in a thread lifecycle thing. It is under the blocked status for some time. Correct. It is under the monitor status. Okay, so after some point of time, if it is quickly released from that status, that is not a problem at all, because obviously any point of time any object will be locked for some time. Lock, that condition is called as locked condition, LOCK. Okay, that everywhere will be happening, guys. You cannot preventing to do a locking condition, because lock will be for a very minor time, there is no problem. But lock will be for a prolonged time, that is a problem. Okay, that is the reason I'm saying you try to take 3 thread dump to 5 thread dump, so that you will be analyzing whatever the things that are locked in the first thread dump, second thread dump, third thread dump, like that. If it is continuously logged, then that is a problem. Because what is your understanding? Say like your first thread dump that you are taking by 9 o'clock, second thread dump you are taking by 9:1, third thread dump that you are taking by 9:2, like that you are continuously taking a thread dump. Say like your first thread dump, one thread id is there, that thread id is available in your third thread id also. Your first thread id, one thread id is there, and third thread dump also the thread id is there. What is that meaning, guys? What is that meaning if it is there for the third thread id also?
It is continuously in a blocked state.
Which means that for 2 minutes, 9192, which means that for 2 minutes it is in the blocked status. Correct or not? That is what the meaning, right? What I told you, 9 o'clock one thread dump, 9:1 one thread dump, 9:2 one thread dump, which means that from 9 o'clock to 9:2 the thread is in the same status. But your SLA would be what? Your SLA would be 5 seconds. Your performance testing world, your SLA would be 5 seconds. Do you really accept if the thread is blocked for 2 minutes, your SLA is actually 5 seconds?
No.
So that is where your problem identification is actually starting. So this is how you have to do your thread dump analysis. So for now what I'm doing, I'm going down. Is there any blocked threads are there? I wanted to investigate. As per the thing, it is saying blocked here. Okay, blocked and blocked here. So it sometimes you need to be a little more investigating, like deadlock condition and all that we will see later in our session. But you need to take multiple thread dumps. This particular blocked status prolonged for multiple thread dumps means then there is a issue. If it is completed in a shorter span of time, then there is no problem, because it is released automatically. It released automatically. But if it is unable to release that object, I gave the printer and I am not releasing that printer at all to Jonathan, then Jonathan request infinitely waiting. Jonathan request is infinitely waiting. That is not the good sign. I have to release that printer so that Jonathan request will be processed. That is where your dead lock or your blocked condition, it is explained in the thread dump concepts. We will see little more detail also, but for now I wanted to set the context. That is the reason we saw this, how to take thread dump, how to do this analysis and all. Okay, any question, guys, till now? Are we guys good with this thread dump analysis, right? You are clear, Dhanasri? Okay, thank you. You are clear, Kumar? Yeah, thank you. So, like this only, guys, we are going to learn heap dump, thread dump, garbage collection, not only using JVisual VM, JConsole. We have lot of online tools are there, a lot of commercial tools are there. We are going to use JProfiler Viewer Kit for that only. We are going to use GC Viewer. There is a tool available, GC Viewer. Like that, we are going to use online tools like Heap Hero, Thread Analyzer, even GC, EC, like that. A lot of tools that we are going to learn. Uh, why I'm telling you this thing is that like. Um, uh, Actually, one of our learner attended interview last month. She was actually went for the interview. They gave one laptop. In that, no facility, nothing is available. But they asked her to do certain performance engineering question to be answered. Actually, saying she mentioned like finally she used JConsole and JVisual VM for the entire activity. Actually, saying there is no commercial option, there is no internet option available in that machine. So she was using that JVisual VM JConsole to crack the interview. So what she mentioned is that like I was under the impression I can use different tools, but finally I got only the JVisual option, JVisual VM option alone, sir. So, but somehow I cleared the interview. So that is the reason we are covering all the different layers, all the different flavor of your tooling option. So in that, JVisual VM is one such option. Okay. So during our regular session, I will show like how to create load. Okay, load for the system. That system is actually fully loaded. That time, if you are taking the heap dump, thread dump, what is happening? If you are taking garbage collection, what is happening? Like that, we will see each and everything practically, guys. Like everything will be practically understanding, so that it will be kind of a work experience, right? Whatever you are see practically, you are going to do it in your local machine also, which will be kind of refreshing things. Like you can also do it in your local machine, set the application, run this program, do your do your investigation, try to understand what is really happening in your heap dump, what is really happening in your thread dump, like that. Clear, guys? Clear with this concept? So for now, what we did is that like I showed you like blocked threads, right? Like blocked threads you are going. Even the waiting threads you have to investigate next. And then runnable threads also you have to investigate next. Don't think like waiting threads or runnable threads also healthy. No. Waiting threads also, if it is infinitely waiting, wrong. Runnable threads also, if it is infinitely running, wrong. So your approach should be like this, which are all blocked, which are all actually waiting, which are all actually runnable. Slowly you have to do your investigation. Okay, I'll quickly show one more behavior also. I'll start my Apache Tomcat server. This and all I will provide, all these dump files and all I will provide, guys, during our regular session. I will provide the Tomcat dump, JDK dump, scripts, program, code, tool, all these things related to repository related to that, will provide it. So that you can also install it in your local machine. I will even show how to deploy this war file into your Apache Tomcat, how your application to be running. All those things we will share. Knowledge repository, everything we will share it. Just a minute. Okay, the server started now. If I quickly go back and go and start the JMeter tool. I'll start one sample script. I have the sample script. Even I'll share this sample script also to you people, because you have to simulate that behavior, right? So what I'm going to do, for now I'm going to monitor this Tomcat. Okay, Tomcat JVM that I'm going to monitor. So if I go to the threads, okay, you can see the Tomcat is actually started, right? The Tomcat which is actually started, and it is initiating the threads now. Okay, all your threads will be there. Okay, which are available now. You can see these are threads. So running status, sleeping status, waiting status, park status, monitor status. Park status is nothing but it is actually created, but it is not doing any activity. It is waiting for something. Monitor status is nothing but what I told you, right? Blocked status. Monitor means it is under the blocked status. Running means running. Sleeping means thread.sleep, and then waiting means it is waiting for some activity. That is what the status. So if I start with some one user test that I'm starting, hitting this Apache Tomcat application. If I hit it, what will happen? Quickly, that one user activity will be coming to your system. You can see out of the available threads, there are requests are started coming. So all your uh, uh, 10 threads that are currently available, right? These 10 threads are sufficiently handling that single user activity. Because of that, it is actually running. It is actually sufficiently handling the load. Everybody able to see this, guys, behavior? Everybody able to see this behavior? It is sufficiently running without any problem. Okay. Say like suddenly what I am doing, I am stopping this test and then increasing the load to 25. If I go, this 10 threads may not be sufficient. You can see straight away it is going to the blocked states, monitor status. That color is actually slightly pinkish color of things, right? So you can see straight away it is going to the monitor status. Monitor status is nothing but blocked. Each and every thread is blocked for some time because this 10 threads unable to handle that 25 user load that is trying to struggle to complete one activity, go to the next thread, complete one activity, go to the next thread. This behavior is actually the realistic real world example, guys. Okay, those who are doing performance testing or those who are doing infrastructure monitoring, they should really see to that. If it is there for blocked status for longer period of time, which means that your running activity is very less. You are unable to withstand this load. You are struggling. Thread congestion, this is called thread congestion. You are unable to handle that load at all. So which means that the number of user that you are trying to give it to your infrastructure is wrong. You are either overloading your infrastructure. That is what the meaning of this 25 user load, which means that you need to sufficiently handle the load. You should not give this kind of a overload to your system. These are all concepts, guys. Okay, this is what we are going to learn each and everything in detail during our regular session. Okay, so those who are interested to proceed further with the course, please reach out to Kumar sir. This is Kumar sir number. At the bottom of the screen, it is there. 80199 52427. 80199 5 to 4 to 7. Please reach out to Kumar sir for further information related to your commercials and other stuffs. And timing is the same time slot, 7 o'clock to 8 o'clock Indian time. I'm saying 7 o'clock to 8 o'clock Indian time, IST time, morning time. It is a weekday session. All these are weekday session. Saturday, Sunday leave. Those who are interested to proceed further, please reach out to Kumar sir for further information. We will probably start our regular session from tomorrow based on the request that we are receiving. Thanks everyone for giving us this opportunity to take this demo session. I hope we'll all travel together in this performance engineering course. Thanks all for joining today's session. Bye bye.